All right, so now that we've done our warm-up, we're going to move into the notes. If you look at the title of this, it says inference for two means. Last class we did inference for two proportions, and this slide was almost the same. We just replaced the word proportion with mean, and then of course now we are not dealing with two proportion z-interval or two proportion z-test, but two sample t-interval and two sample t-test. Those are going to be our new procedure names. So that is a really important first step. So I'll write that at the top. And then we will move on to an example. But just a quick reminder, we use intervals to estimate and we use tests to test claims. And so we're only going to stick with T for means at this point, so you won't have to be confused anymore about when to use Z and when to use T. For this unit, we will use Z for proportions and T for means. All right. So instead of writing a new pass on this slide so that you don't see 15 different passes, what we wrote instead were just the things that changed from last class. So first, we already talked about this, the procedure name changes. And so we'll have these two different procedures that we'll decide between. Of course, because it's a mean now, then our symbol changes to mean 1 and mean 2. We'll have two groups. We'll have one mean from each one. And then, of course, you already know this from the last unit, but the normal condition will change for means. And we actually already know these rules, but because we have two samples, we'll check that both populations are normal. If that's not true, both sample size should be at least 30, according to the central limit theorem. And if that's not true, then you have to draw two box plots, one for each sample, and show that there's no strong skew or outliers. Because we change our type of number from proportion to mean, our formulas will also change, but it's just the symbols in them that change. So for the first one, remember it's statistic plus or minus critical value multiplied by the standard deviation of the statistic. And so what that looks like is x bar 1 minus x bar 2 plus or minus your t star times the square root of each standard deviation squared over their respective samples added together. Then for number 2, the test statistic. Remember, all test statistics have the same format. Statistic, same statistic as the interval, minus parameter over the standard deviation of the statistic. For two sample tests, all parameters are 0 because we're testing that there's no difference for our null against our alternative. And then all T procedures have degrees of freedom. And so right now we're going to be using what's called the conservative degrees of freedom, and you'll just take your smallest sample size and subtract 1 from that one. All right, let's just get started on our first example. So the first thing we want to do is just circle all the important parts. And so we started off in a study of heart surgery. One issue was the effective drugs called beta blockers on the pulse rate of patients during surgery. The available subjects were divided at random into two groups of 30 patients each. One group received a beta blocker, the other group received a placebo. The pulse rate of each patient at a critical point during the operation was recorded. The treatment group had a mean pulse rate of 65.2 and sample standard deviation of 7.8. For the control group, the mean pulse rate was 70.3 and the standard deviation was 8.3. Construct and interpret a 99% confidence interval for the difference in mean pulse rates of the two groups. So let's just label what those things were that we just found out. So first, our two sample sizes, N1 equals 30 and N2 equals 30. Next, we're going to start with our x bar 1. That will be 65.2 beats per minute. X bar 2 is S1 is 7.8 beats per minute. bar 2 is 70.3 beats per minute, and S2 is 8.3 beats per minute. All right, so we just wanted to label everything so that we can use it all pretty quickly in the problem. And then we're just going to go through our regular old past steps. So just follow along and we will, you'll know by the end. All right, starting with the P. For intervals, remember, all we have to do is label the parameters and state the procedure. So this will be called a 2 sample because there are 2 samples, beta blockers and placebo group. T interval for mu1 minus mu2, where mu1 is the true mean pulse rate of my X bar 1 came from the treatment group. So we're going to say heart surgery patients receiving a beta blocker. And mu2, I always think of Pokemon when I say Mewtwo, but mu2 is the true mean pulse rate of heart surgery patients not receiving a beta blocker. We don't want to say of the placebo group because that's only from our sample and we want the mu that we're defining to be for the population. And so we want to say just patients not receiving a beta blocker since that's what the placebo group represents. All right, next we will do our assumptions and conditions. We have the same 3 that we've had since December: random, normal, and independent. All right, with random, we go back, see what the problem said. The available subjects were divided at random. We're going to write divided at random. Normal, we have to start, if our populations are normal, we'll write that. I didn't read anything about that. The next, we should have at least 30 in each sample. So I'm going to write both ends are at least 30. 30 is at least 30 by the central limit theorem. We can stop there. Now, independent's a little different now because we have 2 samples that were divided at random. They didn't come from a large population. They were already there. So we're just going to say random assignment again there because the dividing at random is what makes our 2 groups independent from each other. We'll talk more about that when I get back. All right, next we have our statistical work. We have our new formula to fill in. I'll write it here first: X bar 1 minus X bar 2 plus or minus T star times the square root of S1 squared over N1 plus S2 squared over N2. Fill in what we wrote down. X bar 1 was 65.2. 65.2 minus X bar 2, which was 70.3. Plus or minus. All right, now we need to find the T star for 99%, which we will do in the next video. We'll pause here so I can record a new one.